All right, to continue the lesson on sequences, we're going to move into geometric sequences. So geometric sequence is a sequence in which you have a common ratio being multiplied to each consecutive term. So to go from u1 to u2, you multiply by r. The common ratio to go from u2 to u3, you multiply by r, and so forth. Okay, so we're going to denote that common ratio by a lowercase r. And to find that ratio, you multiply the term by the previous term, and that's how you can find out the common ratio. So for example, if I have, let's say, the sequence 4, 2, 1, 1/2, and so on. Okay, well, you should see the pattern pretty easily. It's dividing by 2. But we never write that ratio as a division. We always write it as a multiplication. So to get the ratio, we can take any two consecutive terms. So let's take 2 divided by the prior term, and that's where we get 1/2. Okay? So when r is less than -1 or greater than 1, we call that sequence a diverging sequence. The sequence is diverging. Okay? When -1 is less than r, which is less than 1, that's another way of saying when r is between -1 and 1, the sequence is converging. And that's going to be important when we talk about geometric series. We're going to use that vocabulary. So just like I did with arithmetic sequences, I'm going to derive the general formula for geometric sequences. All right, so I want you to understand where this formula comes from. So we know if it's geometric that there's a common ratio r between each of the terms. All right, so just like I did with arithmetic, I'm going to write this sequence in terms of u1 and r. So it'll look like this. u1 stays u1. u2 is going to be u1 times r. So this right here is u2. All right? u3 is going to be u1 times r times r. Okay? u4 is going to be u1 times r times r. Times r. 3 r's there. Okay, so again, we're starting to see a pattern within a pattern here. And that is that this sequence can be rewritten as u1, comma, u1 times r, comma, u1 times r squared, comma, u1 times r cubed, and that continues on forever. So again, just like with arithmetic sequences, we want to see a pattern. Is there a pattern to this? Okay, well, all of them multiply by u1. So in our general formula, which is going to be u sub n, to find u sub n, any nth term in the sequence, we're going to take u1 and multiply it by the common ratio. Well, how many times do we multiply the common ratio? Well, noticing the pattern up here, we multiply the common ratio one less times than the term number. So if the term number is n minus 1 is going to be how many times we have to multiply that common ratio. And this right here is the formula to find any general term in a geometric sequence. All right, let's take a look at some examples now. So it says for each geometric sequence, find r and the term indicated. So A, we have 40, 20, 10, and we need to find the 12th term. Okay, well, r, you can kind of see it. It's going to be multiplying by 1/2, right? Because we're dividing by 2. But if you didn't see that right off the bat, you can do 20 divided by 40, which is 1/2 reduced. All right, so we got r. So that means u sub n, the nth term in our sequence, is going to be 40 times 1/2 to the n minus 1, and I'm going to put the 1/2 in parentheses. All right, so we have u sub 12 is equal to 40 times 1/2 to the 12 minus 1. Okay, which is 40 times 1/2 to the 11th power. Now, I would say that this is a calculator problem because 1/2 to the 11th power is going to be 1 over a pretty large number down here. And then you're going to have to multiply 40 and reduce. So, I'm going to say you can do that in the calculator. If you don't know how to do that in a calculator, I'll show you in person. But I got 5 over 256 is my answer there. Okay, so moving on. Part B, we have a little bit tougher sequence. 1/2, negative 1/4, 1/8, and then dot, dot, dot. Notice it's changing from positive to negative. That's an indication that our common ratio is going to be a negative number. All right, so to find that, we would do negative 1/4 divided by 1/2. So when you're dividing fractions, you flip the divisor and multiply. So it's negative 2 over 4, which is negative 1/2. Okay, so that means u sub n is going to be 1/2 times negative 1/2 to the n minus 1. So again, u sub 9, just plug in, use that formula we just built. And again, I would probably say this is a calculator problem. Negative 1/2 to the 8th. It could be done by hand. I mean, you can figure out what 2 to the 8th is. But for time's sake, I'll just throw up the answer. And the answer is 1 over, I got 512. All right. So next problem. Here's the sequence. If you know how fractions or how decimals work, we're moving the decimal one place to the left every time. So that's a division by 10. So if you didn't know that, you could do 8.7 divided by 87. It'll give you 1/10 or 0.1. I'm going to use 1/10. So I have that u sub n is equal to 87 times 1/10 to the n minus 1. All right, so now u sub 6 is going to be 87 times 1/10 to the 6 minus 1, which I'm running out of board space, so I'm just going to erase that and put 5. I believe we could do this without a calculator, okay? Multiples of 10 are pretty easy to do. So the way I think about it, 1/10 to the 5th power is just 1 over, I'm going to have a 1 with 5 zeros after it. So I have 87 times 1 over 1, 0, 0, 0, 0. That's, I need one more 0. Here we go. So my answer is going to be 87 over 100,000. All right? Or you could do it in the calculator, and this may be a calculator problem since the numbers are kind of large. Moving on. This last one, this is definitely a non-calculator. You have variables involved. You can't use a calculator to help you deal with variables. So, what's the common ratio? So we go 7x, 14x, 21, or 14x squared, 21x cubed. Well, it looks like we're multiplying by 2 for sure. And then to go from x to x squared, you got to multiply by x. To go from x squared to x cubed, you got to go multiply by x. So, if you didn't see that, you can do 14x squared divided by the previous term, which is 7x, and you get 2x. So the general formula would be u sub n is equal to 7x times 2x to the n minus 1. And we need to calculate u sub 8, the 8th term. So we have 7x times 2x to the 8 minus 1. Again, I'm going to say that's a 7 just to save some room on the board. All right, 2 to the 7th power. We can do 2 to the 7th. I know 2 to the 5th is 32. 2 to the 6th is 64. So 2 to the 7th is 128. So I have 7x times 128, x to the 7th. So I know my answer is x to the 8th because x times x to the 7th is x to the 8th. I just need to do 7 times 128. Now, what do you do if you don't have a calculator and you can't multiply that in your head? Go old school. Calculate what it is. 896. All right, so there's your answer. That is the 8th term. So in this example, we're given that u1 is 81 and u6 is 1 over 729. Find the values of u2, u3, u4, and u5 such that the sequence is geometric. Okay, so we have u1 here. We don't know the stuff in the middle here, but we do know that u sub 6 is 1 over 729. So in order to find u sub 2, u sub 3, u sub 4, u sub 5, we need to know the general formula, or we at least need to know the common ratio. So once we find the common ratio, we can build the general formula and then use that to find u2, u3, u4, and u5. So let's try and do that. So I know that u sub 6 is going to equal u sub 1 times the common ratio 5 times. All right, so now I substitute my values in. I have 81 times r to the 5th is equal to 1 over 729. Okay, so I need to divide both sides by 81. All right, so when dividing by 81, I'm really multiplying this denominator by 81. So 729 times 81 is, all right, sorry, somebody knocked at the door. So as I was saying, if you divide both sides by 81, 1 over 729 is equal to 1 over 59,049. And then we need to take the 5th root. Of both sides, because that's how you get rid of that exponent of 5. So there is a button in the calculator to change the square root to different roots. If you don't know how to do that, you can also do 1 over 59,049 in parentheses and raise it to the 1/5 power in the calculator. So either way, this is a nice number. It does come out to be r is 1/9. Okay, so our ratio is 1/9. So that means our general formula, u sub n is equal to 81 times 1/9 to the n minus 1. All right, so to find u sub 2, all we do is do 81 times 1/9 to the 2 minus 1 power, which is 81 times 1/9 to the first power, so it's 81 times 1/9, which is equivalent to 81 divided by 9, so that's just 9. So then let's think about it over here. So we multiplied by 1/9 to get U2. U2 is 9. So all I have to do is take that 9 and multiply it by another 1/9 to get U sub 3. So I have 9 times 1/9. I get 1. So U sub 4 is just going to be 1 times 1/9, which is 1/9. U sub 5 is 1/9 times 1/9, which is 1/81st. All right, and then we're done with that problem. All right, so another example. In a geometric sequence, U sub 1 is 5, U sub 5 is 1280. The last term of the sequence is 20,480. Given that R is positive, find the number of terms in the sequence. So we have a finite sequence. We're given the first, the fifth, and the last, which they don't tell us the last, obviously, because that would tell us the number of terms in the sequence. So that's what we have to find. So we first have to find that common ratio. So we know that to get U sub 5, we'd have to multiply U sub 1 times R to the 5 minus 1 power. All right, so U sub 5 is 1,280. U sub 1 is 5. And we have R to the 4th power. Okay, so solve for R. So we divide by 5, and that number is 256. Then to solve for R, since it's raised to the 4th power, we need to take the 4th root. Which R is equal to 4. Now I'm going to pause here because hopefully in algebra you learned when you took a square root or you take an even root, so square root, 4th root, 6th root, you could end up with plus or minus this value. However, in the problem they tell us that R is positive, so we don't have to worry about it possibly being negative. It's going to be positive 4. Okay, so now we go back and say, okay, so U sub n is equal to the first term, 5, times the common ratio 4 to the n minus 1 power. So what is unknown in this problem? Well, n is unknown. The n is unknown for this term right here. So we know that 20,480 is equal to 5 times 4 to the n minus 1. We don't know what that n is. All right, so let's try and get this term right here, or this piece of the equation by itself. So we're going to divide by 5 on both sides. And when you divide by 5, you end up with 4,096. Okay? So, there's a couple different ways to solve. I think the easiest way to solve is to figure out, okay, 4 to some power is 4,096. See if we can write 4,096 as a base 4 to some exponent. And it turns out that 4 to the 6th power works. So if these bases are the same, that must mean these exponents have to be the same. So that means that 6 has to equal n minus 1. Then you add 1 to both sides, you get n is 7. So there's 7 terms in this sequence. Last example. So we have the value of a car depreciates at a rate of 19% each year. If you buy a new car today for $33,560, how much will it be worth after 4 years? So if you're not careful in this problem, you can make a mistake with this 4 years. So I want to explain kind of what this looks like. So the first term in the sequence is that 33,560. Okay, this is the first, this is U sub 1. Okay, but what is the time frame for this value of the car? This is when t equals 0, right? This is when you first purchased the car. So u sub 2, t is going to equal 1. U sub 3, t is going to equal 2. U sub 4, t is going to equal 3. And u sub 5, here's our 4th year. Here's the end of the 4th year. So when we're going to build the formula, we're going to build the general formula, but when we plug into that formula, we're going to find u sub 5, not u sub 4. And that's the mistake that's easily made. So let's look at this. The common ratio, we don't know two values of the car, okay? But they do tell us that it depreciates at a rate of 19%. So how much value is the car carrying from year to year? The car only carries 100% minus the 19% it depreciates each year. Depreciates means it drops. Okay, so it drops 19% of its value every year. So that is 81%, which as a decimal is 0.81. So that's our common ratio. So our general formula is u sub n is equal to 33,560 times 0.81 to the n minus 1 power. So then our answer is going to be u sub 5. Remember that corresponds to 4 years. So then you just plug it in. Okay, and this is definitely a calculator problem. But you get in the calculator, okay, I don't have the exact thing, I have my rounded. So if you're ever going to round, don't use an equal sign. Use the squiggly equal sign. That means u sub 5 is approximately, or the value of the car after 5 years. Now, I know I said the standard for IB is 3 sig figs, okay? But we're dealing with money here. So we should round in a way that makes sense for the context we're given. And in our money system, we have the hundredths place for cents. So I'm gonna round that way. And the answer I got is $14,446.48. So that ends geometric sequences. I hope you find it easy, and if you have any questions, please let me know. Talk to you soon.